Good morning. Today's lesson is going to be zeros of polynomials. Now, what we're going to start with is going to be the easiest thing we have done probably in your entire math life, and that is the fundamental theorem of algebra. And what this tells us is if we look at the degree of any expression or any equation, the highest degree, that is how many solutions or how many zeros it will have. Not all of them will be real or have to be real. They may be duplicates, but it will have that many solutions. For example, in this equation, 2x to the fifth plus 4x squared minus x plus 5, I'm going to look at the highest exponent, which is the fifth, which means this equation, or technically expression, there's no y equals, is going to have exactly 5 solutions. Now, as I said before, they don't have to be real, and they could also be duplicate solutions. So if I got an equation and it turns out that I have x equals 2 different times, my solution can be x is equal to 2 multiplicity 2. And all this is really saying is that it touches the 2 twice. On the graph, you can know it has multiplicity of an even amount if it bounces off the x-axis. Okay, here's your 2 example problems. I want you to use the fundamental theorem of algebra and tell me how many solutions each of these polynomials will have. Pause the video here, try these, you should be done in about 3 seconds. Alright, the highest exponent is 3, it will have 3 solutions. The highest exponent is 4, it will have 4 solutions. Finished. To solve polynomials for their roots, which is where it crosses the x-axis, we are going to set them equal to 0. Then we're going to factor our expression, and we're going to set each factor equal to 0 and solve. Now, I'm going to factor this example for you, and then we're going to talk about this. This has 4 different terms, which means we're going to factor by grouping. If you check for a greatest common factor across the board, there is not one, so I'm going to jump straight to grouping. The factor of the first is x squared. If I pull x squared out of x cubed, I'm left with a single x. 2 minus 2 is 0, so I just have the 3 remaining for the first part. The GCF of the right term is going to be positive 5. And I'm going to be left with 5 divided by 5, which is just 1, so 1x, plus 15 divided by 5, 3. Looking at these two, I have a GCF now of x plus 3. And I have x squared plus 5 remaining. So I have factored this, and now I'm going to set my equation, because I want to find the roots, equal to 0. Now, anything times 0 is 0. So if I determine what makes this expression 0 and what makes this expression 0, I know the numbers that are the roots of this expression. So I'm going to separate this. X plus 3 is equal to 0. X squared plus 5 is equal to 0. Solve the one on the left, I'm going to subtract 3 from both sides. Therefore, x is going to be equal to negative 3. On the right, I'm going to subtract 5 from both sides. So x squared is going to be equal to negative 5. To go to the square, I need to take the square root of both sides. Make sure you include the positive and negative on the square root. So this is plus or minus the square root of negative 5. You cannot have the square root of a negative number, so what we're going to do is pull out the imaginary negative 1 out of this. So plus or minus I square root 5. Now I want you to see how many solutions do I have. If I'll use the fundamental theorem of algebra, Highest exponent is 3, so I need 3 solutions. Do I have that many? Yes, I do. What are my solutions? My solutions are x is equal to negative 3, positive I square root 5, and negative I square root 5. Those are all 3 of my solutions to this equation. Okay, we're going to look at these pages, and we're going to stop for the day. When you feel like you're ready, I do encourage you to try some of these on your own. I'm going to work through the first. I'll just do a couple of problems. I might skip around. I don't really know yet. Alright, number 1. X to the 4th plus 5x squared minus 14. Factoring this, I want the factors of 14, which are going to be 1 and 14, 2 and 7. Let's see, 3 does not work, 4 does not work, 5 does not work, 6 does not work, 7 does, but it's back to this, so I'm finished. Alright, this sign tells me the bigger number needs to be positive. This sign tells me, because it is a negative, these signs need to be opposite. So the small numbers in this case are negative. This is going to give me negative 13, positive 13. This is going to give me positive 5. My factors are x squared minus 2 and x squared plus 7. Notice it's a square because this exponent is 4, this exponent is 2. The difference between them is 2. Therefore, it is x squared instead of just regular x in my factored form. It is equal to 0. Alright, if I separate these out, I really don't need that parenthesis. X squared minus 2 is equal to 0. X squared plus 7 is equal to 0. Before I continue any further, using the fundamental theorem of algebra, FTA, it tells me I'm going to have 4 solutions. So at the end of my problem, I need to make sure I have all 4 accounted for. Alright, for the first one, I'm going to add 2 to both sides. So x squared is going to be equal to positive 2, square root, x is equal to plus or minus square root of 2. Subtract 7, square root. I'm not going to be able to fit in my plus or minus there. Okay. Again, this is a negative 7. I do need to simplify the radical. Plus or minus I square root 7. This is a sufficient answer. It works. However, I'm going to go and write each of them out so you are easily able to determine all 4 of these factors. All 4 of these solutions, rather. So x is equal to negative square root 2, positive square root 2, negative I square root 7, positive I square root 7. Okay, this one is a sum of perfect cubes. So this is the same thing as quantity x cubed plus quantity 4 cubed. My formula, x plus 4. First thing squared, opposite sign, so since this was plus, I need a minus here. Minus, first times second, plus second squared. Okay, simplifying, x plus 4, x squared minus 4x plus 16. I am going to set this equal to 0. X plus 4 is equal to 0. X squared minus 4x plus 16 is equal to 0. Subtract 4, subtract 4. For the equation on the right, I'm going to say x is equal to, and you might know this in a song, negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. If you've not heard the song, it's nothing spectacular, but it's x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. This will tell you what the solutions are to any trinomial equation. So plugging in my values, x is equal to negative 4 plus minus square root negative 4 squared minus 4 times 1 times 16 divided by 2 times 1. Now I believe this is a good time to show you how to use Desmos. So that's what I'm going to do. Alright. Negative 4. I'm going to start with the plus portion. Square root. I'm going to do this math just because it's easier for me to say it and actually type it in that way than type in all the symbols. But negative 4 squared is 16. And minus 4 times 16 is 64. Times 1 is 64. All over 2a, which is 2 times 1, which is just 2. Alright, I have an undefined. The question is, why do I have undefined? Well, let's just type in the equation from the beginning. If I type in x squared minus 4x plus 16, might have I put in the right symbol, I have this graph. It is not touching my x-axis. Okay? What does this tell us? There is no zeros to this part. They are imaginary. So what do I need to do? It's actually quite simple to solve from here as far as what the answer needs to be. I am going to say, if I can copy on my iPad, and I cannot, which is wonderful, I'm going to say, I'm going to simplify each part of the term. So this is 4, negative 4 is positive 4, plus or minus, I can't really type it in, but plus or minus, square root. Okay, 16 minus 64. So that's going to give you 48. If I take this 48 and remove the negative, is 6.92828, so it doesn't give me a perfect square. What I can do, though, is break this down into its prime factorization and pull out factors to simplify the radical. So, instead of having negative 48, I'm going to say this is going to be, first, I for the negative. For 48, I'm going to be doing 16 times 3. The square root of 16 is 4. So this is 4 square root of 3. So 4i square root 3. 2 times 1 is 2. I'm going to write this down first, I'm going to show you something else to do. 4 plus or minus 4i square root 3 over 2. I want you to notice, though, this is not completely finished. Why not? Because we have a GCF on top. If I pull out a 4, from this equation as being aggravating to what I want it to do, I have 4 over 2. 4 divided by 2 is just 2. So this final answer would be 2, 1 plus or minus I square root 3. So my 3 solutions. X is equal to negative 4, which is by far the easiest solution. 2, 1 plus or minus I square root 3. I'm going to write it this way for all 3 solutions. I'm not going to break apart the plus or minus, simply because I don't want to. Now, I can hear some of you, even though this is a video, saying, well, Mr. Myers, this is way too long. Can I simplify this any down? Yes and no. The yes method is to cheat, and I'll show you that. As we have already established, this is negative 48. However, if I'm given answer choices, such as the 2 parenthesis 1 plus or minus I square root 3 that I have here, I'm going to retype this in. And the way I'm going to cheat is I'm going to take out the negative. Is it the correct answer? No. Will it help me find the correct answer? Yes, because if I have answer choices such as the 2 parenthesis 1 plus, and again I'm taking out the imaginary, square root 3. So I'm taking out that negative radical. Notice my answers match. Can you solve it like this? Not mathematically, but you can use what I'm going to call mathematical common sense to say, if I take out the negative, the answers match. If I put the negative back in, even though they're going to say undefined, they're still the same answer, okay? So can you shorten it? Yes, but maybe not in the way that you're wanting to, okay? But there is a little bit of a shortcut you can use, so I did want to show you. All right, let's look at number 3. I might be doing both. Okay. Number 3. And this is not drawing for y. GCF is x, so I'm going to pull out an x. I have left x to the 4th minus 2x squared minus 3. Okay, first, I'm going to be looking for 5 solutions from this. FTA, 5 solutions. Alright, I'm going to factor the right side now. So I'm going to leave the x where it is. The factors of 3 that add to negative 2 is going to be x minus 3 and x plus 1. Again, this is x squared instead of just x because my exponents are decreasing by 2 and not 1. Alright, I'm going to set this equal to 0. X is equal to 0. Okay, that one's finished. X squared minus 3 is equal to 0. And x squared plus 1 is equal to 0. Solving the middle one, I'm going to end up with x is equal to plus or minus the square root of 3. This one, it will be plus or minus the square root of negative 1, which is I. So what I really have is x is equal to plus or minus I. So my solutions, x is equal to 0, negative square root 3, positive square root 3, I, negative I. I don't like that. Negative I, positive I. Okay, there's all 5 solutions. Let's start from the beginning and type this in Desmos. I'm going to completely start over in this problem. X to the 5th minus 2x cubed minus 3x. Notice right here I have 3 real solutions. Namely, these 3 real solutions. So if the test question you received said, identify the solutions, the real solutions of this problem, there's your 3 numbers. With answer choices, if I type in square root of 3, it matches that one. Of course, 0, 0, negative, well, try this again, negative square root 3 is the last one. The only thing we had left was the positive and negative imaginary solution. Number 4, I'm going to give you the encouragement to type everything in Desmos first to see how many solutions you receive. I am looking for 5 solutions in this problem. Well, that didn't work. I thought I saw something cool whenever I was trying to type stuff in earlier, and apparently I was wrong. Okay, here's my graph. I have a solution at 0 is what it says. So out of the 5 solutions, this is saying either I'm going to have multiplicity or only one of them is real. So let's take a look at it. X for the GCF, x to the 4th plus 2x squared plus 1. This is going to be x squared. My factors I'm going to use is plus 1 and x squared plus 1. I could say this is going to be x squared plus 1 squared. Notice right here, whatever my solutions are, I have a multiplicity of 2 on this portion. So I'm going to set this part equal to 0. So first, x is equal to 0. And I'm going to write with multiplicity of 2. Meaning whatever my answers are, it happens twice. X squared plus 1 is equal to 0. This is going to give us, like it did over here, same equation, x is equal to plus or minus I. And again, that is with multiplicity of 2, meaning it's, if you want to say it like this, happens twice. It's plus or minus I and then plus or minus I again. What are my solutions? X is equal to negative I, positive I, positive I, 0. Finished. Okay, number 5. I'm going to factor out by grouping. Before I do that, what will make this problem easier? I could do it my way, but I'm actually being nice for a change, and I'm going to make it easier for you. Every term has an x. I'm going to pull out an x from the very beginning. I'm going to actually pull out 2 x's from the very beginning. So it is going to be x squared. And now, 2x to the third plus x to the second plus 10x plus 5. Okay, with grouping, which I'll denote in green here, my GCF is going to be x squared, and I'm going to be left with 2x plus 1. GCF of the second is going to be positive 5. I'm going to be left, again, with 2x plus 1. Now if I take both of these together, I'm going to have, well, here we go, x squared. I'm going to pull my 2x plus 1 out. And then I'm going to have x squared plus 5 remaining. I want you to notice at this point, I need to be looking for 5 solutions. I'm going to write them up there probably. So I'm going to set this equal to 0. X squared is equal to 0. 2x plus 1 is equal to 0. X squared plus 5 is equal to 0. Square root, x is equal to plus or minus square root of 0, which is plus or minus 0. This is really just 0 twice. You can't have negative 0. For the second one, subtract 1, divide by 2, so x is going to be equal to negative 1/2. For the last one, x is going to be equal to plus or minus the square root of negative 5, which is plus or minus I square root 5. So my 5 solutions is going to be x is equal to 0, 0. So this is multiplicity. 0 multiplicity of 2. Negative 1/2. Negative I square root 5. positive I square root 5. I'll type this in. Before I get it finished, I want you to be thinking about, what do you guess, if you're just going to make a complete blind guess, what would you think this graph is going to look like? I would like to recall your attention to what I said at the beginning whenever I first mentioned multiplicity. And that is, if you have multiplicity, it's going to bounce off the value. So, this graph shows me 3 solutions. There's one, the negative 0.5. This 0 is 2. How do I know? Because instead of passing through the graph, it touches that 0, the x-axis, and bounces back off. Okay? From the graphical standpoint alone, I could tell you right there is 3 solutions out of the 5. Let's look at number 1 on the next page. I'm going to type this in Desmos first. And for this one, I'm going to give you these directions. And I want you to try this before you see me do it. Find the real solutions. You could consider these 4 problems as your practice, but I'm just asking you to find the real solutions only. So pause the video, try these, unpause it when you're ready to continue. Okay, so I'm going to solve these. X to the 4th plus 2x squared minus 15. Because this said find the real solutions, I do not have to factor anything just to get the answer, because I just want to know where it's equal to 0. So, for number 1, I'm going to have negative 1.732 and positive 1.732. There are my real solutions. Now, this will be actually a radical if you was to solve it by hand, but it really doesn't matter for us. It is going to be these numbers if you want to know the radical. Probably should put in the other one. Negative square root 3. There would be the, let's say, unapproximated answer. Okay, these are the same thing. If you don't know that, you could factor by hand, or you type in answer choices, or you could use the rounded decimal and say approximately. I really do not care which way you prefer to do it. Okay, next one, x cubed minus 8. I have one real solution. I suppose I should put my x equals here. X is equal to 2, finished. Okay, this one I'm looking for 5 solutions. I want to know how many of these are real. Looking at this graph, take a moment. How many of these do you see? The answer is not 3. Look at the turning points. It is turning on the x-axis. My solutions are negative 2, because it bounces off at negative 2. It goes through 0, so 1, 0, and it bounces off at positive 2. So I'm going to do 2 twice. There's all 5 solutions. Alright, last one. Plus 4x to the fourth. That's a minus, not what I wanted. Okay, this one has 5 solutions total, and it's going to have 3 real solutions. X is equal to -4, and then 0 twice. Okay, we're done for the day. Now, real quick, I want to ask you the question, why did I take the time and show you, and change this to just be real solutions, and show you how to do it in Desmos? Because on your EOC, you have an allotted amount of time. You want to make the use of it wisely and to the best of your ability. Meaning, if you get questions where you can just use Desmos so you can have more time to think on problems that are harder. Well, that's all that I have for you today. If you have any questions, please let me know, and I hope you have a great rest of your day.